So this is our next problem. You've got gear A, which is this one, A in mesh with gear B. If A starts from rest and has a constant angular acceleration of 2, determine the time needed for B to attain an angular velocity of that much. Okay. Gear A. Alright, so you've got A and B. Let's list down all our information. Gear A is rotating. Alpha A is equal to 2 radian per second squared. RA is equal to 25. Do we know omega A? We don't know. What else? Determine the time needed for B to attain an angular velocity of 50. We also don't know alpha B. We know RB. This one we don't know. RB, do we know? Yeah, it's 100 mm, and omega B is 50. When it becomes 50, what is the time? Do we know the time? So this is all the information that we know. Okay. So A is rotating. This is something called a bevel gear. If you look from the sides, you're gonna see something like this, lah. This is a bevel gear. This is the gear, some sort of like that. This like that. So when this driver gear, this driver gear rotates, is it like that? It's the other way around, eh? When this one rotates like that, it goes like that, huh? So this one will rotate like that. So any action that way will rotate this one that way. Am I right to visualize? Yeah, this is correct. Okay, you are trying to solve what's going on at B. So you need all this information at B. Definitely you need this one. You need what is alpha B. Yeah, so this is not so hard. You can try it on your own. So you can use the relationship between alpha A RA equals alpha B RB. Use this information. So alpha A is 2. Radius is 25. Alpha B you don't know, but the radius you know is 100. So you're going to get alpha B as 25 times 2. 25 times 2 divided by 100. Alpha B is actually 0.5 radian per second squared. Okay, so if you know what is alpha B, which is solved, 0.5 radian per second squared, you need to get T lah. Okay, which formula do you use? List down the formulas that you have. 1, formula 2, formula 3. All these formula we have tried already. Which one is good? 1 at a time, 2 at a time, 3 at a time. You cannot use number 3, of course. Number 2, you don't have displacement information. You don't have angular displacement. So you need to use formula number 1. Use formula number 1. Omega is equal to omega naught plus alpha t. So if the omega becomes 50, originally starts from rest is 0. Alpha is 0.5. What is time? Yeah, you got the time. It's 100 seconds. So next thing that we are going to be doing is something called gear ratio. So you know about this relationship already. Omega 1 R1 equals omega 2 R2. Or you can use omega 1 T1 equals omega 2 T2. So you can use teeth. So for example, at the back here, this one has 30 teeth. At the front here, it has 60 teeth. So what should we do about it? What is the gear ratio? In order to do this, let me bring up a new screen. So at the back, you have 30 teeth. At the front, you have 60 teeth. So gear ratio is equivalent to the easiest format to remember is this output. The easiest format to remember gear ratio is output over input. So your output is your load. Your input is your driving. Is your source driving. Or sometimes you're gonna write like this: driven or driving. It's like that So I guess the best method is this one output over input. What is your output? What is your input? So you have to remember if you have a motor and your motor has a small pinion, it's driving a bigger chain, this is your input. This is your driving. This is your load. Let's say this one is connected to a fan, a big fan. However, you have to look at case by case Look at this bicycle, driven and driving. So the ratio would be the driven is 30 teeth. The driving is 60 teeth. This one, the ratio will be 1/2. Because you are driving this one. And your load is at the back. So the ratio is 1:2. Can we use the output over input? Output is this one Input is your driving. Driving is 60 teeth. Can we change teeth to radius? Can. This one is a bigger radius. R1 bigger than this one. You can even change from teeth to radius. Or diameter. Diameter also can. The ratio would be same. Output over input. So how about this one? So don't look at the answer yet. How to close your eyes from looking at the answer. This is the driver, the effort. So this is the input. This is the load, this is the output. So output over input lah. 75 divided by 25 teeth. So the ratio is 3 over 1, 3 to 1. Again, this is 4 to 1. So what does this mean? For every 4 rotations of the driving gear, the driven gear makes 1 rotation. Okay. Okay, so few more exercises to do, then we can wrap this up, this exercise on a few more. A lot more, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we'll do half of it. Alright, so this is, again, you should pause the video and do yourself first. Okay, pause the video. Pause the video. Hit space and do yourself first. If you don't understand, then proceed with the video to make sure you understand on how to do it. Okay. So this is the, I'm going to try to do the solution. So let's look at this one. This is a reverse gear in automotive transmission. Okay. Engine turns the shaft A. So shaft A is your input. Shaft B is your output. This is your output. So remember gear ratio. Teeth output over teeth input. Something like that. Or R output over R input. But this one is not so straightforward anymore. This one, you have to go through a lot of gears. You have to go through a lot of gears in order to get the output. There's a lot of configurations. But one thing for sure, you have established this before. If your gear is in mesh, this is A, this is B, this is RB, this is RA, it will have common velocity at meshed region. This is your V. So the common due to common velocity, VA is equivalent to VB. So due to this, you can get something like omega A RA is equal to omega B RB. So this works. So you gotta do step by step. You have to do it for this one, G and C first. Okay, so let's try a couple. Let's do omega A times R omega A R G equals omega C R C. This is the first coupling of it. Omega A is 40. Radius A. Oh no, not radius A, right? It's radius G. RG. RG. RG is what? 80 mm. So 80. Omega C. This one rotates like that. So this one will rotate like that lah. Omega C we don't know, but the radius for C is 40 mm. So omega C, immediately you're gonna get lah. How much? 80 radian per second. So this thing, this whole shaft is rotating at 80 radian per second. If this one is rotating at 80, over here also is actually rotating at 80. So you know already this is actually omega D. So next formula will be omega D times RE equals omega E RE. So 80 kali RE berapa? 50 times unknown RE is equal to 50 also. Are we looking? This one is not correct. This one is wrong. RD. RD is 40. Omega E RE. This one is correct. So it's important to maybe rectangle your formula so that you don't reference wrongly. Omega E RE. RE is 50. So you're going to get omega E is equal to 80 by 40 divided by 50. This one is actually 64 radian per second. So this one rotates at 64. So this one will also rotate at 64, which is omega F. If this one rotates at 64, this one will rotate like that lah. Omega B. Okay. So final one. Omega F RF is equal to omega B RH. (64 by RF). Berapa? RF 70. Omega B, I don't know. RH 50 mm. So omega B is equal to 64 times 70 divided by 50. 89.6. 89.6 radian per second. Okay, so our input was, this is our input, 40 input. Our output is 89.6. Uh, 89.6 radian per second. So, okay, there you go lah. Alright, so next. So how about gear ratio? How do we convert this into gear ratio? Look at our formula for gear ratio. It is always driving and driven. This is the driven and this is the driving, but this one is looking at teeth. How do we change this to speed? Is it just plug in or it is the other way around? Seems like it's the other way around, huh? Maybe V is equal to omega R. V is equal to omega R. So the relationship between radius and teeth and omega is inversed. Okay, so V over omega is equal to radius. It becomes like this. So radius is proportional to 1 over omega. So it's like that. So it's slightly a little bit confusing if you choose this method. So you got to convert properly lah. It's reversed. Okay, next. How many more exercises, huh? Again, as I've told you again and again, pause and do on your own. OWN. If you don't understand, then you proceed with the video lecture. Okay, so let's break down this machine. This machine is called a plane or a planar. So it makes the surface become a plane. I think in Malay we call it pengetam kayu, some sort like that. It flattens the surface. So blade C of the power plane is driven by pulley A. Blade C is over here. This is the blade. It's driven by a pulley A. Mounted on the armature shaft. This one lah. Mounted on the shaft of the motor. If the constant angular acceleration of pulley A. Okay. Let's review all our knowledge. I guess you got to convert this to 2D in order for you to understand. Let's convert. This is a... I should go higher. This is your motor. This motor has a pulley. So this pulley, the radius is RA. 25 mm. Okay, if the constant angular acceleration of pulley A is 40, omega A, it's not given, but they give you something called alpha A. It's a constant 40 radian per second squared. This one they give. So this motor is hooked up by a belt. So there's a belt. This belt is mounted there. So this belt rotates. Rotates what? Rotates this one. This other pulley. This other pulley is called RB lah, the radius B. 50 mm. Omega V, do you know? We don't know. Do we know alpha B? We don't know. But we want to know what is the angular velocity of the blade. Okay. The blade is located on this shaft, and now you have the blades. Okay. So it's direct coupling. The blade's radius is, this is C. This is A. This is B. RC is 75. What do we want to know? Determine the angular velocity of blade. Angular velocity. So dia nak cari omega C berapa at the instant A has turned 400 rev. When theta A is equal to 400 revolution. Why lah so kebat this question? So many information that you have to really understand. So if you are in charge of more complicated machineries later on when you go to work, you need to understand all this. All these pulleys and belts. What do they do? How are they affected? So that's why you got to learn this properly, in order to make any mistakes at work. So what do we do now? I guess the best way is to identify the source. This is your source. This is your source. The source is your motor. You have a lot of things going on here. When theta A has rotated 400 revolution, apa nak cari? I suppose dia suruh cari ni kan, omega kan. Yeah, okay, I got it. He's trying to get you to know this. Omega C. You know already the relationship of omega with radius. Omega C RC equal omega, this one is directly coupled. Omega C is actually equivalent to omega B. Why? Same shaft. Yeah, same shaft. So you don't really have to find out what is omega C. You just have to find out what is omega B. Just find out this one. Ini berapa? Then you solve the thing. Because they are similar. Then this one looks easy. Am I right? So, when theta A has rotated 400 revolution, what is this one lah? What is omega A? So if you know omega A, you can use the formula lah. Okay? Use the formula of omega A RA is equivalent to omega B RB. If you solve omega B, this one. If you solve this one, you solve omega C because they are similar. Okay, so now we gotta know omega A first lah. Seems so easy, right? Omega A is equal to omega naught plus alpha T. Does it ring a bell? I cannot use this because there is no T. No T, cannot use this. And there is no time. There's no choice lah, you gotta use this one. Omega squared is equivalent to omega naught squared plus 2 alpha theta minus theta naught. I use this one. This one will give you a lot of information. No time. There is no time. So omega we don't know. Omega not. Originally at rest? Yeah, has to start from rest, huh? 0 squared plus 2 alpha. Alpha do we know? Yeah. Alpha is 40. Theta is 400 times 2 pi minus 0. So this one is omega squared, so don't forget to square root. Whatever you get here, square root. 400 times 2 times 40. 2 kali 40 kali 400 kali 2. 6400 pi. 6400 pi square root. Square root. So you get omega apa? Omega A lah. This is omega A. 448. 448.4. This is omega A. So if you know omega A, you can use the relationship. Which relationship? This one. So where should I plug in? Make some space, huh? Oh, we don't need to know. You can solve using this one. Omega A RA. Omega A RA is equivalent to omega B RB. Omega A berapa? We know already. 448.4. Radius A 25. Omega B do we know? We don't know. RB is 50. So omega B is equivalent to times 25 divided by 50. 224 omega B. Omega B is 224.2 radian per second. So I was surprised this answer is wrong, but it's actually correct lah. This one is omega A. It doesn't tell you omega B. Okay. This is correct. Next. This one. How to hide? You should hide this one first. You should hide this one first and then try to do it on your own. Let me hide things for you. Insert shape. There you go. It's hidden. Now it is hidden. Okay, pause the video and do this on your own. For a short period of time. Doesn't look so bad, right? Does this look so bad? Let's understand this. How many more do we have? Plenty more. 1, 2, 3, 4, 5, 6, 7, 8. I suppose this is very important. That's why you gotta learn how to solve this, because you'll be dealing with a lot of machines and machineries. For a short period of time, the motor turns gear A with a constant angular acceleration. Where is gear A? Okay, this one. 4.5. Determine the velocity of the cylinder and the distance it travels in 3 seconds. Okay, velocity. VC and SC. VC is traveling linearly. So this is meter per second. SC is meter. Doesn't look so bad. It looks so easy. Yeah, you gotta analyze it. 75, 225. This one is 125. This one is in mesh with each other. Shouldn't be so hard. So the thing that you should know is alpha A is 4.5. They are in sync with this one. So this big disk is B, so you need to find first alpha B berapa lah. Very easy lah. You should pause now. Alpha A, RA is equivalent to alpha B, RB. Alpha A is 4.5. The radius is 75. Alpha B you don't know. The radius is 225. So alpha B is equivalent to alpha B is actually 1.5 radian per second squared. If this is rotating at this one rotates like this, they are on a similar shaft. Oh, okay, something wrong, the direction of motion is not this way. VC actually goes up because this one rotates like that. And you know already, alpha B is equivalent to 1.5. So rotates like that. So what do we need to know? We need to find out what is omega B. What is omega B? What is this wheel omega? And you know omega B will be equivalent to omega D, which is this small one, because they are connected to the same shaft. So how do we find out this one? Kena carilah dulu omega A ni berapa. What is omega A? In 3 seconds 3 seconds. Cari dulu berapakah omega A. Omega is equal to omega naught plus alpha T. Use this formula. In 3 seconds, look at from omega A. Omega A. Omega A you don't know. Starts from rest. There you go. 0 plus. Oh, you don't have to know A. You can definitely analyze B, right? Yeah. You don't have to go back so far. You can analyze omega B because you already know this one. Alpha B you already know. So omega B is alpha B berapa? 1.5. How do you know this? You use this relationship. Done. Time. After 3 seconds, omega B becomes 4.5 radian per second. This is after 3 seconds. Okay. If your omega B, since it is sitting at the same thing, if you guys cannot visualize this, you have to visualize from the top. If I draw from the top, it is something like this. This one is A. This one is B. This B is connected to another one, which is D. Something like a double pulley, but different diameter. So omega B is 4.5. If omega B is 4.5, omega B is also equivalent to omega D. So this D bucket, this one, this D bucket, this D circle is actually rotating at 4.5 radian per second lah. So if you want to find out what is VC, V is equal to omega R, right? This V is tangential. When we say tangential, it's this one lah, tang V. In this case, it's actually VP. What do you call this? Prime. VP prime. So it's equivalent to omega. Omega berapa? 4.5. Radius dia berapa? 125. So 0.125. 4.5 times 0.125. 0.5625. So V, P, prime 0.563. Don't get it wrong, it should be meter per second. Ada jawapan tak? Ada jawapan hidden I gotta remove this thing also. Remove this thing. Ya betul, 0.563. Correct lah. 0.563, similar to what we get lah. What else? We need to find displacement. You can find displacement using 1, 2, 3, third formula probably, or second formula. So one thing you need to take note is the first formula, second formula, third formula that you are getting can only be used for this one, constant angular acceleration. Okay, so you guys should proceed and try to find S. Which formula to use? Use formula number 2 lah probably. Maybe formula number 3 Maybe formula number 3. Formula number 3 also maybe can use. Okay, next. This one I guess I gotta explain to you guys this one. What's inside? If you guys can really you need to try to convert this to 2D plan view. If you cannot convert this to 2D plan view, you cannot solve this system. So take a break, draw on your own. Pause the video and draw on your own. What does this look like if you are looking from the top? Look from the top. What do you see? In a 2D plan view. Okay. Done. Okay, so this is the view lah. This is the view from the top. This one is actually a bevel gear. Some sort like that. This one. This is A. This one is kind of connected to this one. B. What is this? This is B. And B is connected via a same shaft to another gear. So this one is a gear, gear. This one is a big gear like that. And then it's finally connected to the driven. Which is driving this thing lah, this thing out. This is the load lah. This one is another gear. So this is C, this is D. So if you can convert something like this, then you are good to go. You have very good imagination. Yeah, okay. So that is that lah. That's solved. The motor turns gear A. So that its angular velocity increases uniformly from 0 to 3000. 3000 RPM after the shaft rotates 200 revolution. Okay kah? Determine the angular velocity of gear D when time is equal to 3 second. Dia suruh cari omega D berapa when time is equal to 3 second. This is what he wants you to find. What is this omega D after 3 seconds? Radius A berapa? 25 mm. Radius B 100 mm. Radius C 40 mm. Radius D is actually 100 mm. This one looks like that one lah. Looks the same. Remember, omega 1 R1 equals omega 2 R2. It is similar to that one. Only thing is you got to analyze here, jump. And then analyze on this shaft along, jump. After 3 seconds, since this is the output, and you need to find the output at time equals to 3 seconds, right? 3 seconds. You need to study what happens here. This is the source. When time is equal to 3 seconds. You got to look at that. So, angular velocity increases uniformly from 0 until 3000 RPM after the shaft turns 200 rev. Macam mana tu? Okay, so let's look at the source. Source. What about the source? Study the source in order to solve everything. CE tak ada. Source. Where is your source? This is your source. Study this one. So it says here, omega naught is equal to 0. Omega is equal to 3000 RPM. When theta hits 200 revolution. There you go. Apa boleh cari kat sini Tapi dia tak cakap pun. What is omega when time is equal to 3 second? Omega ni berapa? It doesn't tell you this. If you can find out what is omega when time is equal to 3 seconds, you can jump using the formula lah. What formula? Omega 1 R1 equals omega 2 R2. But you have to find out this one first lah. So information we have is in terms of theta. So you can use this one lah. Omega squared is equal to omega naught squared plus 2a. Not a, right? Alpha. Do we have alpha here? Theta minus theta naught. You are trying to find alpha. So berapa alpha? Omega squared. Final omega 3000 lah. So 2 pi 3000 over 60 squared equals omega naught squared 0 plus 2 alpha theta. Theta is actually 200 rev. 200 kali 2 pi. Dapatlah alpha. Once dapat alpha, cari berapa omega. How to find omega? Use this formula. Bukan V it comes from V V is equals to V naught plus AT. So omega is equal to omega naught plus alpha T. Omega naught 0 alpha, get from here. This one. T, 3 seconds. Dapatlah omega. And then you get the omega source. Complete it, okay? So solve this one. Okay lah, let's solve it together. Cari dulu. Alpha ni berapa? Alpha is equal to 3000 times 2 pi divided by 60 squared bahagi 2 shift pi bahagi 2 bahagi 200 bahagi 2 39.27. This one I get 39.27 radian per second squared. So I gotta plug in this one lah. 39.27 times 3. Berapa omega? Times 3. 117. 117 radian per second. 117 radian per second. So you gotta look at this one lah. How to solve this one? I don't have the space. I suppose I gotta make this one smaller, bigger, smaller. How do I make more space? I want to jump this one. Omega here you know already. 117.8 actually. Radian per second. So you gotta jump. Ini macam dah betul, tapi ini jawapan ni kot, jawapan omega A. I suppose this is omega A lah. But this is not what you're trying to find, right? You're trying to find here. Determine the angular velocity of gear D. This one, omega D berapa. So you gotta jump here and jump here and jump here. Like the one that you did on this one. This one is even more complicated. Do the same thing. Do the same thing here. Okay, I guess it's good. Let's look at another problem. This one, there you go, some exercises for you to do. This one looks eerily similar to this one. This one, right? Remember? Almost similar. This one is also almost similar. This one, probably not so similar. Okay, I guess we'll do one more. Okay, this one we do. This is the last exercise for this lecture. The rest of the questions, you have to do it on your own. Try to understand how to do it on your own. We're going to do this exercise 11. What are we looking at here? This is a mechanism for a car window winder. Car window winder. In the what 80s. So in the 80s, we don't really have power window. We use our hands to rotate a crank, and there are sorts of gears inside, and it will wind up or wind down our car window. But now this hand has been replaced by a motor. But the rest of the calculations remains the same. That's the thing. Okay, let's do this. Handle blah blah blah. The window is free to slide on the track. If the handle is wound at 0.5 radian per second, determine the speed of point A and E. A and E. And the speed VW ini of the window at the instant theta is equal to 30 degrees. Theta is equal to 30 degrees. So this angle right here degrees. Okay, how do you look at this properly? It's some sort of like a free body diagram. You have to convert this to something that you can really understand. So one thing that you can really understand is this is the sprocket which is driving the whole thing. Circle, okay. This one is rotating at, we gotta give this a name, omega c 0.5 radian per second. RC 20 mm. This one is connected to this semi gear. Although it looks like a semi gear, it's actually you don't have to draw a semi gear. Draw a full gear lah. This full gear. This one. So if this one is rotating like that, this one will rotate like that lah. This one is called C. This one is called B. Omega. So RB is 50 mm. Omega B berapa? Boleh cari kan? So easy. Let's do a short one here. Omega C RC equals omega B RB. Omega C 0.5 kali 20 equals omega B RB. 50. So omega B becomes 0.5 times 20 bahagi 50. Dapat 0.2 radian per second. Is it good or not? Much slower This is 0.2 radian per second. Much slower rotation. And then what else? Yeah, you gotta crack the code. Look at this beam. This beam is actually rotating like that, with a center here. So if you really draw this beam, I'm gonna draw it with the yellow color. It's like that lah. It's like that. So it is like it's like a big circle lah. It's like that. So what is it called A kah? Over here is actually A, right? So A is actually rotating like that lah. So from this one, you know that omega B is actually equivalent to omega A, because it's on the same rod. Center of rotation also same. So this thing is actually rotating like that lah. Okay kah? Yeah, so if you look at this properly, look at here. This is actually, so since it is rotating, it rotates like that omega A is equal to 0.2. So tangential velocity here is actually VA tangential like that lah. So V is equal to V tangential is equal to omega R. Omega is 0.2 times radius. Berapa? Radius dia besar kan? 200 mm. 0.2. So 0.2 times 0.2, 0.04 It's actually 0.04 meter per second lah. Correct lah. But in this linear direction, it's not this direction. We want to find out this one, vertical direction. So this one is definitely 30 degrees coming from here. So you know velocity as a vector. If this vector is actually 0.04, what is this vector? And you know also the angle between the vectors. This is 30. What do? You use cos, right? So what do you call this one? Vy kah? So Vy is equivalent to V cos 30 degrees. V ni apa? V tangential lah. 0.04 cos 30 degrees. 30 degrees dapat berapa? Zero point 0.866 0.04 kali cos 0.04 kali cos 30. Dapat jawapan. It's actually 0.03 0.46 meter per second. Okay, so vector is in force. Kita cari ni je. Kita cari, kan dia buat rotation macam tu. This is the velocity tangential that you get. So there you go. This is being calculated at like this lah. At 30 degrees. And 30 degrees only. Kalau dia berubah jadi 31 degrees, sudah different. So it's actually you gotta plot V versus theta or versus time. Berapa dia punya velocity? It's gotta fluctuate lah. Or behaving linearly, depends lah. Or slower or bad. Yeah, this one you have to analyze properly lah. And you can use a computer to do this. What other problems do we have which is interesting? How about this one? Can you guys? Doesn't look so complicated, eh? Let's draw from the side. This one also not so complicated. This one looks very interesting. Driving this wheel, and then there's a gear there. There's another gear. It goes to a shaft. It goes to this final gear. This is what? Can opener. Okay. Why do we do this all gears? Why? Why gears? Why? This is something that you will learn later on. It is because you want to play around. Not play around lah. You want a variable. The torque and RPM. Later on you will learn something like power is equivalent to torque omega. Power is equivalent to torque omega. Where does this come from? It comes from force times velocity, right? If you still can't remember, force times s over time ka? Velocity is also over time, right? This one, velocity is equal to force times omega r also. And F times R times omega. F times R is actually torque lah. So that's why you get torque omega. Oh, this one correct lah, but no need to review. So power is actually torque times omega. So when you have multiple gears, this is your power over here. Let's say you are giving it 100 watt. Through all these gears and with some efficiency, probably your output is going to be like 95 watt. You are giving 100 watt, your output will be 95 watt. So, ideally, there is no losses lah. Ideally, let's look at ideal case first. Let's say your input is 100 watt, your output is also 100 watt. So in between, power here is similar to power here, is similar to power here, is similar to power here. So you can use the relationship of torque 1 omega 1 is equivalent to torque 2 omega 2. There you go. So if you want a higher speed, let's say this is 100 watt. If you want a higher speed, you will have, if this is higher, this one will be lower torque. Similarly, if you want, let's say T3, omega 3, if you want higher torque, your speed will be lower. So this is why they play around with a lot of gears. So you can generate high amount of torque in certain application. By slowing the rotation of the gear. If you have a very fast rotation of the gear, you will have lower torque. So this is why engineers use gears in their designs. Okay, so the rest you can try it on your own. Okay.